All right, this is part 3 of Learning Module 1. So, Learning Module 2 took about 40 minutes. This won't take 40 minutes. But learning part 2 of Learning Module 1 actually took a good bit of time talking about the software development lifecycle in general. This part of Learning Module 1 just want to talk about some very specific instantiations of the software development lifecycle. Certain organizations build software a certain way. They don't follow that generic approach I was talking about in part 2, that software development lifecycle, but they follow some flavor of that development lifecycle. So let's see what some of these variations might look like. Okay, so some of these different approaches, sometimes they'll be called a prescriptive process model, by the way. Remember the 3 quality characteristics, or the 3 characteristics we talked about in the software engineering, that it was systematic, disciplined, and quantifiable. So these prescriptive models have been developed with that in mind, so that organizations can pick up a prescriptive model or a specific development methodology and implement it, and they know that there's some rigor to it. There's step-by-step procedures. It's discipline, meaning it's repeatable. There's ways to measure each of the steps, and we'll talk about them here as we go through them. Okay. So there's kind of 3 to 4 categorically development methodologies. The first is more of a structured, and that's our oldest, that came out in the 70s. Development methodologies, we call it the waterfall methodology, or the classical. And then there's the V model and the incremental. So let's talk about those for a second. So the waterfall is very simple to think about. Remember our development life cycle. You have planning, analysis, design, implementation, testing, and O&M. And basically how they are processed, how the flow goes, is you go from one to the other. It's very sequential, very linear. We go from the planning phase to the analysis phase. Then we go to the design phase. Then we go to the implementation phase. So it's kind of like water that's in a stream that's flowing downstream. That's why they call it a waterfall. You're just going from one phase into the next. Okay, very linear. So let's talk about this for a second. This concept, very easy to understand. It's easy to measure in the sense of, and it's easy to enforce certain things. Like during the planning phase, we're going to achieve X, Y, and Z. I can put a schedule together to do X, Y, and Z. Now let's go get her done. So it's easy to understand. It's easy to convey up front. However, you rarely see this in practice. We don't really follow this approach. I mean, I say we rarely do. You have some organizations that do. I mean, I do in my outside employment where I work. We follow this approach on some projects. For projects that have been around for a long time, they followed this approach in the beginning, so they're going to continue following it. You don't mix the development approaches, okay? So you still see it, don't get me wrong, and you still see it a good bit. However, it's horrible approach to take if you don't know your requirements that well. Okay, so during the analysis phase, when we're trying to understand what requirements need to be built into the system, if it's a tough problem to solve and we're not really sure of the requirements, I shouldn't say complexity of the problem. I mean, that contributes to it, but it's not, the ultimate factor. But if it's just hard to pin down what the requirements are, like if I'm building something for you and you're not really sure what you want built, but you need something, that's hard. Then that's going to be difficult to pin the requirements down, to basically extract the requirements from you. This approach would not be good for that, taking a waterfall approach. Okay, so if you can't state all the requirements up front, don't take this approach. Okay. Customers also have to have a lot of patience, because you have to go through all of these phases: planning, analysis, design, implementation, test. Boom, now you start seeing a product. So the customer might have to cut some checks early on, and they don't get to see a product till late in the life cycle. Okay, so this is tough. This is tough. Okay, then we move into something called the V model. The V, see how it looks like the character V, the letter V. Look at the phases: planning, analysis, architecture, design, implementation. So really this design phase got broken out into two phases: system architecture and component design. And then going up the right hand side of the V, you have the testing, the different types of testing that gets conducted. This is no different than the waterfall or the classical approach. It's the same activities. All this model does is show the correlation between testing, our quality assurance activities, testing, and which phase is it being correlated to. So when we have the system architecture phase, when we're doing integration testing, we're focused on testing the system architecture. When we're doing system testing, we're focused on testing the system architecture as well as testing the requirements. And during acceptance testing, we're focused on testing the requirements. So the V model, all it does is bring the quality assurance activities and shows you how it's related to the different phases. Okay. And then the last one we're going to talk about, the prescribed approach for the structured prescribed approaches, is incremental, to where you still have the phases, kind of like the waterfall. You got the planning, analysis, design, implementation, testing, O&M, and all that. But we're going to do them in increments. So we're going to do one whole series of those phases, and that's going to be increment 1. Well, increment 1 might have just a very basic set of functions for our software. Like, for example, over here I say, well, we're building a word processing application, okay? For our word processing application, increment 1 only consists of file management and document production. So we're going to go through this entire life cycle, and we're only going to be building these features into the software. That's going to be increment 1. Then we're going to come back and just repeat all of those phases again: planning, analysis, design. We're going to repeat that for increment 2, which just adds more functionality to the software. And then increment 3, 4, all the way to N. Okay, so you're still following the same linear approach, the classical approach, but you're breaking it down into, you're only solving certain features of the software per increment. Okay. All right, then we transition into more of an evolutionary modeling approach, or evolutionary development methodology. And the main one that you follow in there is prototyping. Okay, and prototyping is where early on we develop a model of the final solution. It's not a completed solution by any means. If you take the word processing application that I was just talking about, and what you might do is you might have a GUI, the graphical user interface of what all of the what it might look like, and then you might have a menu bar for all of the different options that the user could select, but they don't do anything. The purpose is you're sitting the customer down, or the end user down, in front of your prototype to basically elicit ideas and feedback from them. What do they think? So you're getting that feedback early on. They're getting to look at it and see what it looks like, so that they can come back and say, well, I wanted it to be pink. I wanted to be able to, interact with my phone, this whatever. So the prototype is just a scaled down model. And once we basically establish that, then we can evolve that prototype to what it needs to really look like as a fully functional software application. So the concept of an evolutionary model is you still go through a lot of these phases. You do a quick planning session, you do a modeling and quick design, you build something really quick, a prototype, you get it in front of the user so that they can give you some feedback. So that's that communication step. And then you go through it again and you start evolving that model to a final software end product. Okay. There's some great advantages and disadvantages to taking a prototyping approach. We use it a ton, by the way. You see this a lot. So all these advantages are applicable. Some of the main disadvantages, though, one of the bad things it does, especially with end users and customers, since they see a scaled down version, they think you're done. They're like, oh, well, just add that and you're done. They don't realize that, whoa, we didn't build anything into it. It just has very minimal functionality. And so sometimes the end customer doesn't really realize that the prototype is just step one, and so they think you're almost done. So it could set some bad expectations for you as a development team. So, anyways, go through these. I'm not going to read them all to you. And then the last evolutionary model we're going to talk about is a spiral. So in looking at this spiral, look right here where it says start. Okay. So in this start here, think of this as a record, an album. If any of you know what an album is, where on an album there's only one track on an album. Okay. And so you're basically running around this track. If you see my cursor, my mouse cursor, and it's just so it's getting us further and further out. Well, basically what it's doing is this. So here I am at the start. I'm going to start communicating. So this section of my diagram, I'm going to start communicating with the customer, the end user, and all that. Then I'm going to enter into the planning phase. Then I'm going to enter into the analysis phase, implementation, and I'm going to deploy. So it's very similar to the prototyping approach, to where, okay, I'm going to get more feedback here, and then I'm going to go through this loop again. And I'm eventually building more features into the software application. Very similar to the prototyping. Prototyping had a lot more, didn't do so much of the planning and the analysis. It spent more time in the implementation in the prototyping. So both of them are very similar. And they still go through our life cycle, as we talked about early on. It's just they go through it a different way. The process is a little different as well. Okay. And then some of the latest approaches, I say latest, it's been around forever, but it's really caught on, especially with internet applications, web-based applications, the Agile approaches. And there's different Agile approaches. One of them is called Scrum. It's borrowed from playing rugby. If anybody plays rugby, the idea of the Scrum, where again, we're focused on, if you think about the incremental approach, or if you think of the spiral approach, the idea of the Scrum is we're going to identify a set of features that we want to build into the software, and then we're going to take a subset of those features, and we're going to say, okay, we're going to build this set of features into the system first. Then we're going to build the next version is going to have a next set of features, and then the next version. So keep that in the back of your mind as we talk about the Agile approach called Scrum, okay? So to start off with, you identify yourself a sprint, okay? And you typically just a time box. Let's just say it's a month. You can pick longer, 2 months. You can pick shorter, 2 weeks. I probably wouldn't do that. I mean, 1 month is about as good. I'd really want to know what the system you're building, and then your desired deployment is like, before I would muck around with this 1 month. But whatever, you pick a time box, okay? And that basically identifies what your sprint, the time frame of your sprint, okay? The goal is, at the end of this sprint, we're going to ship a product. It's going to be working. It's not going to be a prototype. We're going to be a workable product, okay? So, first things first, with each sprint, we're going to start looking at what we call a product backlog. Very key, you got to understand that term, a product backlog. The product backlog consists of all the features that need to be built into the software, all of them. And it's the requirements, okay? So the product backlog consists of all the requirements for the software that you need to build, okay? So what we do is we start each sprint with a sprint planning session, and we identify those features or requirements from the backlog, the product backlog, which ones we want to build into this sprint, okay? Once we identify which of those requirements or which of those features we want to build into this sprint, those features then become our sprint backlog. And those are the features that we're building into this shippable product at the end of sprint 1. Okay? During the sprint planning stage, the customer is heavily engaged. They're involved every step of the way. Okay? Each day during this sprint, we have a daily scrum. It's a stand-up meeting. Literally, people stand up. You do not sit down. It's quick. You go around the room. How are things going? What'd you work on yesterday? How did it go? What's it look like today? And each person goes. So we try to keep communication fluid, and we try to keep it quick. Okay? And then at the end of the sprint, we have a review, including the customer. We go through what we did, what we built, how's it looking. And then after we deliver that shippable product, we then have a retrospective, where we basically do pause and learn. We look back at what went well during this last sprint, because we're getting ready to engage into sprint number 2. So what can we learn from sprint number 1? Okay. So let's talk about this in a little bit more detail. Okay. So here's that little picture that you just saw on the previous slide, each sprint. Okay. So basically you have multiple sprints because you need them so that your entire product backlog will get built. Okay. Remember, your product backlog represents all the requirements for the system that needs to be built. Each sprint represents a subset of those features or requirements. Okay. So it's the aggregation of all the sprints. That makes your final product. Okay. So during this picture, let's break this down. For each sprint, I'm going to go into the planning and I'm going to go into the analysis phase. What this analysis phase is going to produce is the sprint backlog. Okay, I'm going to go through these, and then my sprint's going to be for 30 days. In 30 days, I'm going to go through design, implementation, test, operations, and maintenance. Deploy it. That's my shippable product. So I'm going through my development life cycle, but I'm doing it in 30 days, and I'm doing it just on a subset of all the features that need built into the software, and that's called my sprint backlog. So I do that. Then I come back up here, I go through another planning analysis, which identifies sprint number 2. Come down here, I create my next sprint backlog, and then I go through design, implementation, testing, O&M. In 30 days again, I'm shipping the modified version that has more features in it now. Okay, and then I'm just keep going. Okay, now what's critical in this approach, and I spend a little bit more time on this approach than any others because it really just depends on where you go work. A lot of folks do follow the Agile approach, but it's a lot of the new folks that work on internet-based applications, web applications, things like that. But it's the latest approaches, so it's good that you're familiar with the classical, but it's also good that you're familiar with the latest and greatest though as well. But now the key part that's underlying this Agile approach is what we consider object-oriented, or OO, object-oriented methodologies, concepts, and whatnot. Okay, characteristics of object-oriented methodologies and models. Number 1, it utilizes UML, Unified Modeling Language. You're going to get some bits and pieces of UML in this class. You're not going to be proficient in UML from this class. It'd be beneficial. I don't know if you're looking to work in the software world as far as managing software projects, leading them, working as analysts on a software project, becoming a tester. I don't know. But if you do plan to do anything like that, then learning UML is beneficial. Okay. Number 2, everything is use case or user story driven. And you'll see an example of these here in a minute. But anyways, the use case basically defines the system as how somebody's going to use it. Okay, the focus is on how the end user will use the system. And so when you're talking Agile and Scrum, and I said earlier that you had the product backlog that represents all the requirements needed for the system. Well, what are the requirements? What do they look like? They look like use cases or user stories. Okay, you're going to see one here in a second, but the use case is basically used to show, it represents how the end user uses the system. Okay, some other key characteristics, it's very architecture centric. You have different views in how you look at the software. You get a functional view, and that's basically the user's perspective. A static view, basically the structure of the software, all the classes and relationships that's in the code, and whatnot. The last 2 characteristics that drive object-oriented concepts is it's iterative, meaning it's continuous testing and refinement, okay, and incremental. Over time, you're going to evolve the system. You're not going to establish all the requirements up front, build or design a solution for all those requirements, build everything all at once, and then deploy. You're going to go incrementally. Okay. All right. So again, the object-oriented approaches utilizes use cases and user stories. A user story, US, contains what the user's role is, their goal, and what's acceptance criteria. Okay. A use case contains the equivalence of that, but it adds a lot more information to it, like who's actually involved. We call that an actor. What are the flow of events that occur? Like the user, when they want to get the balance of their account, what's the actual actions or steps that they take to get the balance of their account in an ATM machine? And so you got to go through each one of those steps, all right? So there's similarities between the use cases and user stories. The differences, the one major difference between them is that the user story is not as detailed as the use case. Okay, but the user story is meant to basically trigger a conversation. That's the whole point of a user story. Think about the Agile approach. One of the things I stressed is that the customer is engaged in the entire process, heavily engaged. Okay, the user story, or the customer and end user, is heavily engaged. The user story is not meant to basically represent everything that's needed, because it's meant to start a conversation between the development team and the end user and customer. Okay, so that's the whole point of the user story. The use case is different. The use case is trying to capture everything. Okay, so they're used for different purposes. Okay. Here's one example, and you'll see on the next slide another example. But a user story is just a node. It captures what the user does, for what reasons. Here's the template for it. Every user story follows this template. Like for example, as an administrator of the system, I want everyone to be credentialed when they access the system so that I can maintain the integrity of the data. Okay. So again, the purpose is to start the communications with the end user. And then here's an example of a use case. It captures that user point of view and how they might interact with the system. You have who the actor is, who's doing the interacting. It's an employer. The bubble here represents the action or the activity, the process that they go through. It's called managing vacancies. Okay. And then here's a little bit more detail for you. So here's a use case diagram right here. This whole picture right here is a use case diagram. You'll see the various actors. You got a scientist, the environment, the developer, the operator. They're involved. And then here's all the use cases. One, acquire images. The scientist acquires images. That's how you're going to read this. The scientist acquires subsystem performance. The developers learns electronics and all that good stuff. The operator, payload integration, integrates the payload into the habitat. Okay, so this is the actor. They're using our system. So you picture our system as if it was already built, that it's finished, a black box, if you will, and you identify, just pretend it's done, and then you look at how each end user is going to actually use the system, and you start drawing bubbles for each of those uses. Okay. Then what you do is you take each one of them and you elaborate. And the use case has a structure. You typically have a goal, success guarantee, the actors, preconditions, triggers. So let's walk through this a second. In this use case diagram, this is a project that flew in the total solar eclipse in 2017. So one of the use cases is that the science was obtained. The goal of this use case is that images of the solar eclipse are acquired along with altitude and the time of day. So that's what this use case is trying to depict, that it's going to achieve this. Okay. The success guarantee. What does success look like? Well, the images are every 500 feet are taken and all that good stuff. Here's the actual steps, the main success scenario. So the system senses a change in altitude. The system takes an image, an altitude reading, the lat long reading, and time of day. The system stores the data and all that good stuff. Extensions represent what is failure. If for some reason one of these steps fail, we need to identify what do we want the system to do. Okay, the whole purpose here, again, this is the analysis phase. We're generating these so that they go into the product backlog and eventually make a sprint backlog so that it gets built. But this represents our requirements. This is what makes the backlog. This is what folks are going to implement, because they're going to pluck this out of the backlog and say, I'm going to work on it. Okay, let's see. Do I understand everything that's in here? Okay, I need to design a solution for it. I need to write the code for it. I need to test it. And then boom, that's going to be a shippable product in 30 days. Okay. So that was the concepts of the object-oriented approaches, and then here's a little table that was taken from Systems Analysis and Design with UML. The authors were Dennis, Wixon, and Tegarden. They basically just put together when you pick which methodology. Okay, it's a good rule of thumb, good table to go by. A lot of times this will be defined for you by the organization. Okay. All right, so that was pretty much part 3. That's the end of Learning Module 1 that went over the specific instantiations of the development lifecycle that you might be introduced to, depending on where you go work. And then here's 3 questions for you to think about to basically as you digest this material in the videos. Okay? All right. I will see you in the Learning Module 2.